Here's an explanation and solution for exercise 41 of preliminary chapter 1. We are asked to find all x for which the following inequality holds. Absolute value of x plus 1 larger than absolute value of x minus 3. Now we can't just shift around x's and 3's and 1's because there's this annoying absolute value. So let's first look what the solution is graphically, and then afterwards I show you how to do it computationally without drawing anything. So first forget about the left side of the board and look at the right. Since we thought a lot about functions on Friday, it's nothing special for you to think now that x plus 1 absolute value is a function f of x and the absolute value x minus 3 is a function g of x. And then the question of the exercise translates for which x is the function f of x greater than the function g of x? Well, I can just really easily draw f of x and g of x. This is what you see below, f of x in white and g of x in red. Now the question is, where's the white above the red? And we immediately see that's the case for all x's that are greater than 1. For 1, it's not true. For 1, they're equal. So the solution to this inequality is all x of the real numbers that are larger than 1. Great, exercise solved. But now you probably want to know how to resolve absolute values in inequalities in general. And that is something we do by using cases. If the absolute value was gone, that would be nice, right? X plus 1 larger than x minus 3 or something like that is really easy. So don't be afraid of absolute values. We just do it several times for easy cases. What is the absolute value of x? Well, it's plus x if x is greater than 0, and it's minus x if minus is negative. I'm using exactly this, so absolute value of x plus 1 is x plus 1. If the thing in the absolute value is positive, this means for x greater equal to minus 1. And it is minus x plus 1, which is minus x minus 1. Just multiplied what's written inside the absolute value with a minus. For whenever this is negative, that means x smaller than minus 1. And now resolve the absolute value of x minus 3 in the same way. When is x minus 3 positive? That's positive for x greater equals 3. So x minus 3 for x greater equals 3. And minus times this, everything where x minus 3 is negative. That is for x smaller than 3. And now we see that we have 3 cases to consider, namely everything that is smaller than minus 1, then everything that's between minus 1 and 3, and last case, everything that's greater than 3. So we'll do one after the other. And now our inequality becomes really easy for each case. So let's do it. First case, x is smaller than minus 1. For x smaller than minus 1, x plus 1 absolute value is minus x minus 1. And absolute value x minus 3 is minus x plus 3 because our x is smaller than 3 if it's smaller than minus 1. So we are resolving the absolute values with the 2 equations that I pointed the arrow at. For these x, the inequality is minus x minus 1 greater than minus x plus 3. Okay, and that you can easily move around to get 0 is greater than 4, and that's never the case. So no x that is smaller than minus 1 will fulfill this inequality. Next case, x is between minus 1 and 3. So now we have to use x plus 1 and minus x plus 3 for the left and the right side of the inequality. And that gives x is larger than 1. Okay. So it's true for x is larger than 1, and we know that they should also be smaller than 3 because we're restricted to only x's between minus 1 and 3 in our case. So we cannot say yet that the inequality is correct for all x's greater than 1. Here we can say that it's true for all x's that are greater than 1 in the interval that we are considering. So 1 smaller than x smaller than 3 is here the solution. So from the second case, we figured out that the inequality x plus 1 absolute value greater than x minus 3 absolute value is true for all x between 1 and 3. Last case, x is greater equal than 3. Exactly same story again. What are the forms of the absolute values that it takes for x greater than 3? That is x plus 1 and x minus 3. So we write that for the inequality, resolve it and get 0 is larger than minus 4. And that is true. So that tells us for all x that we considered here, for all x greater equal to 3, our inequality is true. And combining the three cases, we get as solution all x that are greater than 1 and all x's that are greater 3 from the third case. We get the solution all x that are greater than 1 fulfill the inequality that we were supposed to solve. Maybe some of you still don't see quite why there were three cases. So here's a little extra explanation for that. We need to find the intervals on which the resolving of the absolute values x plus 1 and x minus 3 do not change. So the boundaries of the intervals are the zeros of the function in the absolute value, that is minus 1 and 3. And this gives us three cases: everything that's smaller than minus 1, the things between minus 1 and 3, and everything's greater than 3.